Welcome to HSEEG.
You know, when you hear the words OSHA crane standards, what pops into your head? Probably some dusty, super dense rulebook, right? Well, what if we looked at it differently? What if we saw it not as a rulebook, but as a blueprint, a life-saving blueprint for operating some of the most powerful machines on Earth? I mean, just look at these things. They are absolute marvels, literally reshaping our skylines. They can lift thousands of tons with incredible pinpoint precision. But with all that power comes a whole lot of risk. One single miscalculation, one little mistake, and the consequences? Well, they can be catastrophic. So that brings us to the big question, right? How do you possibly manage all that risk? What's the actual blueprint for keeping a multi-ton machine safe, especially when it's operating hundreds of feet in the air on a crazy busy construction site? To figure that out, we're going to walk through the blueprint itself. We'll start with its foundation, then look at the chain of responsibility. We'll cover the three main pillars of crane safety. That's securing the site, knowing the machine, and controlling the zone. And then we'll finish with the single most important idea that holds the whole thing together. So let's start at the beginning. A blueprint for safety. You know, every single workplace safety standard in the United States, doesn't matter the industry, it all has the same origin story. It starts right here, with the Occupational Safety and Health Act of 1970. This is the absolute bedrock of our entire blueprint. And the mission of the OSHA Act, it's really simple, but incredibly powerful. It's all about protecting people. So the crane standards we're digging into today, they're just a direct application of that promise, a very detailed plan to keep workers safe in a really hazardous environment. Okay, so we've got the mission. But on a hectic construction site, you've got multiple companies, right? So a huge question comes up. Who is actually responsible for safety? Is it the operator, the person who owns the crane, the general contractor? Who's on the hook? And this is what's so fascinating. OSHA actually splits the duty. The controlling entity, that's usually the general contractor, they're responsible for the ground the crane sits on. But the crane user, that's the operator's employer, they're responsible for the machine itself, its operation, its maintenance, all of it. So the key thing to get here is that safety is a shared legal responsibility. It's not just on one person's shoulders.
All right, let's build on that with our first pillar. Before a single bolt is turned on that crane, safety starts right here, on the ground. You have to remember, a crane's stability is only as good as the earth it's sitting on.
And the blueprint is crystal clear on this. The ground has to be firm. It needs to be drained and graded correctly. And it has to be able to support not just the crane, but the crane plus its maximum load. If the ground is unstable, the entire operation is compromised before it even starts. So, once we have a solid foundation, we can move to the second pillar, the machine itself. A crane is an incredibly complex piece of equipment, and its mechanical health is totally non-negotiable. This is where a really rigorous system of inspections comes in.
And this shows the layered approach perfectly. It's a three-tiered system. First, every single shift starts with a visual check by a competent person. That's someone who can spot hazards. Then, every month, there's a more detailed, documented inspection. And finally, once a year, a qualified person, someone with a degree or tons of experience, does a full deep dive inspection.
Now let's really focus on a critical component, the wire rope. This is literally the muscle of the crane, and its condition is a matter of life and death. The blueprint gives us exact, unforgiving criteria for when a rope has to be retired. 6. I want you to remember that number. If an inspector finds 6 randomly distributed broken wires in one rope lay, that's basically the length it takes for one strand to wrap all the way around the rope, that rope has to be removed from service, immediately. Or how about this number, 3? If you find just 3 broken wires, but they're in a single strand within one rope lay, the result is exactly the same. The rope is out of service. Now, these aren't suggestions. They are absolute limits designed to prevent a catastrophe.
Okay, on to our third and final pillar. We've secured the ground, we've checked the machine, now we have to control the space around the crane. And in this zone, the number one danger isn't falling loads, it's electrocution.
20. What do you think this number is? It's not a weight, it's not a speed, it's a distance. 20 feet. This might be the single most important distance on any job site. It is the default minimum clearance from a power line that's carrying up to 350,000 volts. Getting inside that zone can be instantly fatal. But check it out, it's not always 20 feet. The blueprint that's more precise. This is OSHA's Table A, and it shows how that clearance changes with the voltage. Yeah, you can get closer if you know the voltage is lower, but you have to be absolutely certain. This is not a guessing game.
So we've covered the foundation and the 3 pillars, but there's one more piece. This is the keystone, the part that locks the entire safety blueprint together. And it's not a rule about distance or equipment, it's a rule about authority.
This is directly from the standard, and it is so powerful. It says the operator must have the authority to stop work. This completely transforms the operator's role. They aren't just someone following orders anymore. They are the ultimate guardian of safety. If something feels wrong, they have the power and the duty to hit the brakes.
And that's really the ultimate takeaway here. This blueprint is way more than just rules about ground conditions and power lines. It's a system that gives everyone, especially the operator, not just the responsibility, but the authority to ensure safety. Which leaves us with a big question. In a culture that's always pushing for speed and deadlines, how do we make sure that authority is always respected?
Okay, let's dive into the unseen world of crane safety. I mean, just look at them. It's like they're defying gravity itself. So what is it that really keeps them from toppling over? Well, I can tell you it isn't magic, and it's definitely not luck. No, it's a meticulous system of engineering, planning, and an unwavering, hardcore adherence to the rules.
So here's how we're going to break it all down. We're going to start from the ground up, literally, with the unseen foundation. Then we'll get into the assembly process in waking the Titan. After that, we face the invisible danger of power lines, jump into the operator's seat for the view from the cab, and finally, we'll meet the essential ground crew. Let's get right into it.
Right. Before a crane even lifts a single pound of steel, the most critical work has already happened, and it's right here. Because a crane is only as stable as the ground it's sitting on.
You know, here's a detail that sounds so basic, but it gets overlooked way too often. The rules from OSHA are crystal clear. The ground has to be firm, drained, and graded. And why is that so important? Well, because if that ground shifts, even slightly, under all that immense pressure, the entire machine can become unstable and just go over. And that can happen even if the operator is doing everything else perfectly.
So, whose job is it to make sure the ground is okay? Well, the regulations have a specific name for it, the controlling entity. Basically, this is your prime contractor, your construction manager. They have the ultimate responsibility to guarantee the ground is safe. They also have to tell the crane team about anything that might be hidden underneath, like old pipes or foundations. All right, once that foundation is set, it's time to build the Titan itself. And that brings us to the art of assembly. This is not like putting together some furniture from a box, believe me. This is a high-stakes, incredibly complex process where a single wrong move can be fatal.
So, there are only 2 ways to do this by the book. Option 1, you follow the manufacturer's procedures down to the letter. Option 2, you have what's called a qualified person develop a unique set of procedures. But here is the big, non-negotiable rule. If the manufacturer says, never do this, you just don't do it. Period. End of story.
The person in charge of this whole dance is the assembly/disassembly director, or A/D director. And this isn't just some manager. This person is the conductor of a very dangerous orchestra. They're responsible for every single pin, every bolt, every connection, making sure the crew is safe and everything is done exactly as it should be. The pressure on them is just immense.
Now, the regulations use 2 very specific terms here, and you really need to know the difference. You've got a competent person and a qualified person. Think of it this way. A competent person is like your first responder on site. They can spot a hazard and they have the authority to stop everything right there. A qualified person is more like the engineer or the surgeon. They have the deep knowledge, maybe a degree or tons of experience to actually solve the complex problem. And that HSEEG director, yeah, they have to be both.
Okay, the crane is assembled. Now we have to face the single most lethal threat on any construction site. It's often silent, it's almost always there, and it is completely unforgiving. Overhead power lines.
So let me ask you, what do you think is the #1 killer when it comes to cranes? Is it collapses? Maybe dropped loads? The answer, tragically, is electrocution. Contact with a power line is the single greatest cause of death. It's not even close.
So the whole game is about maintaining distance. And this table, Table A from the OSHA standard, shows you the hard and fast rules. For a typical power line, say up to 50,000 volts, you need at least 10 feet of clearance. Absolute minimum.
But look how that distance jumps as the voltage goes up. At 350,000 volts, you're looking at 20 feet. These are not suggestions, folks. These are life or death measurements.
The protocol for dealing with this is a clear, three-step process. First, you figure out if any part of that crane could get inside a 20-foot bubble around the line. If the answer is yes, you move to step 2. You either get the utility company to de-energize the line, which is always the safest option, or you commit to maintaining that strict clearance. And if you can't kill the power, step 3 is mandatory. You have to use safeguards, like a dedicated spotter or alarms, as your final line of defense.
All right, let's climb up and move into the nerve center of this whole operation, the operator's cab. From this one seat, the operator wields an incredible amount of power, but they also carry an immense weight of responsibility.
Now, the most sacred document in that cab is the load chart. This defines the rated capacity, which is the absolute maximum the crane can lift under very specific conditions. And we need to bust a dangerous myth right now. Some people think the built-in safety factor is a buffer for overloading. It is not. That safety factor is there to handle dynamic forces, wind, the load swinging a bit, not so you can lift more weight. Pushing past that rated capacity is just gambling with physics.
The systems inside that cab are split into 2 groups. First, you have safety devices, things like boom stops or the level indicator. These are non-negotiable. If they don't work, the crane does not work. End of story. Then you have operational aids, like the device that weighs the load. If one of these fails, the rules might allow you to keep working for a little while, but only if you have another accurate way to get that same information.
An operator's focus has to be absolute. The rules are so explicit, no distracting activities, which means no personal cell phone use. They have to stay at the controls anytime a load is hanging in the air. For really heavy lifts, they have to test the brakes beforehand. And here's the most important part. The operator always has the authority to stop a lift. If they feel anything is unsafe, they are not only empowered, they are required to say no.
But hey, the operator isn't alone up there. A safe lift is always a team effort, and that's where the ground crew comes in. They are the operator's indispensable eyes and ears.
So when do you actually legally need a signal person? The rules are pretty simple, and they're all about safety. If the operator can't see the load or where it's going, you need one. If the crane itself is moving and the view is blocked, you need one. And if anyone involved in the lift simply thinks it's necessary, guess what? You need one.
And this brings us full circle, right back to that invisible danger. A dedicated spotter is a special kind of signal person. When you're working near power lines, their only job, their sole responsibility, is to watch that gap. They do nothing else. They don't help with rigging, they don't answer their phone, they just watch that critical distance and talk to the operator. That's it.
So in the end, every single rule we've talked about, from checking the firmness of the ground to a spotter's laser focus, it all traces back to this one powerful idea from that original 1970 Act. These aren't just regulations in some dusty old book. They are a promise written to make sure that the men and women who build our world get to go home safely at the end of every single day.
In any given construction site, there's this silent language being spoken. Get it right, and multi-ton loads get where they need to go safely. Get it wrong? Well, the consequences are absolutely catastrophic. So today, let's dive into your official OSHA explainer on the critical rules of crane communication. I mean, just think about it. With all the noise, the machinery, the chaos of a busy work site, what's the most powerful safety tool you have? It's not the fanciest harness, it's not even your hard hat. It's a signal. A simple, clear gesture is literally the one thing that stands between a safe lift and a total disaster. So, that begs the question, right? In this incredibly high-stakes game, how can we be absolutely certain that every single signal is seen, that it's correct, and that it's understood instantly? Because even a tiny misunderstanding can have massive, massive consequences. That's exactly what we're going to break down. First up, let's talk about the stakes involved, because when communication fails, or just isn't there in the first place, that silence can be absolutely deadly.
I want you to put yourself in the operator's seat for a second. More often than not, you are flying completely blind. From up there in the cab, you probably can't see the load, you can't see exactly where it's going, and you definitely can't see all the hazards in between. You are 100% dependent on your signal person, your eyes on the ground, to guide every single move you make.
And that's precisely why OSHA, the Occupational Safety and Health Administration, doesn't leave any of this to chance. They have a very strict mandate that covers the what and the who of crane signaling.
And here's where it all comes from.
The rules of the game are laid out in black and white in OSHA standard for cranes and derricks. Specifically, we're talking sections 1419 to 1422 and 1428. These sections create the entire safety framework that every site has to follow. And let me be clear, this isn't just a good idea, it's the law.
Okay, so that leads to a big question. When do you have to have a signal person? Is it all the time? Well, the law is very specific about this, and it is absolutely not optional.
It really boils down to three main triggers. Number one, and this is the most common, the operator just can't see the whole picture: the load, the landing spot, the path it takes. Number two, if the crane itself is on the move and the operator's view gets blocked. And number three is this really important catch-all: anytime site conditions or safety concerns make it necessary. Basically, when in doubt, you need a signal person. Now, OSHA uses some very specific language, so let's get this straight. First up is a competent person. This isn't just someone with experience. A competent person is someone who can spot a hazard and, this is the key, has the authority to stop the work right then and there to fix it.
Then you have a qualified person. This is different. A qualified person has proven they have the goods, whether it's through a degree, a certification, or just a ton of experience. They're the ones who can solve the tough problems. They're the subject matter experts.
And here's where it all connects. Your signal person must be a qualified person. That means they have to know the signals backwards and forwards, they need to be good at giving them, and they have to understand the basics of how the crane works, including what it can and can't do. It's not a job for just anybody.
Okay, so we've covered the who and the when. Now let's get into the how. What does this language of the lift actually look and sound like out on the job? You've basically got two options: hand signals and voice signals. For hand signals, you can't just make stuff up. You have to use what's called the standard method, and you've got to have a chart posted nearby so everyone's on the same page. If you're using voice signals, like radios, the rules are just as strict. You got to test them on site, use a dedicated channel so no one cuts in, and the operator has to be hands-free.
All right, lean in for this one because it is probably the most critical and most easily confused rule of all. Every single direction, swing right, swing left, you name it, has to be from the operator's perspective, sitting there in the cab, not your perspective on the ground. You mix that up, and you're going to send a multi-ton load in the exact opposite and very possibly catastrophic direction.
But, you know, even the best plans can go wrong. So what happens when the signal is lost, when the radio goes dead? OSHA has a non-negotiable protocol for this. It's the ultimate fail-safe.
So picture it. You're mid-lift, the radio suddenly sputters and dies. Or maybe the signal person just walks behind a stack of materials and the operator can't see them anymore. What's the move? Well, there's only one correct and one legal answer.
And here it is, plain and simple. The second that line of communication is broken, for any reason at all, the operator must safely stop all operations. Not slow down, not try to guess what the signal is going to be, a complete and secure stop. It is an absolute rule that, without a doubt, saves lives.
And to keep things from getting chaotic, the chain of command has to be crystal clear. The rule is simple: one crane, one signal person. That's it. You can't have two people on the ground yelling different directions. It has to be one clear, authoritative voice for the operator.
But there is one huge, powerful exception to that rule. And this is something every single person on a worksite needs to know. Anyone, and I mean anyone, who sees an imminent danger has the authority and the responsibility to give an emergency stop signal. Safety is everybody's job in that moment.
So when you get right down to it, a clear signal is way more than just a gesture. It's a lifeline. It's a bond of trust between the eyes on the ground and the hands on the controls. So you have to look at your own site, your own team, and ask the tough question: is your communication protocol strong enough to really be your last line of defense?
معانا أهم وأحدث المشاريع الإنشائية، وما تنسوش تعملوا لايك وتشتركوا في القناة عشان يوصلكم كل جديد.